before we go to the problems point of view, I will give you one shortcut method and I will give you a few key points to solve the match filter receiver. Almost all the questions are repeated, means signals may be different but the questions are same. But any question, now how to answer that particular question, okay? So I will give you a 3 points which is very useful to you to solve the problems in a match filter receiver. Now already we will take one example. No? Now this is the input signal to the filter. What we are taking is, this is the input signal to the filter, is a rectangular pulse. This is the input signal to the filter, right? Now this is the input signal to the filter, and what is the output of the filter? Now, the output of the filter you are getting this much, right? The output of the filter is nothing but is a rectangular pulse. Now compare these two and we can form a few points or important relations, okay? Now see here. Now that is input to the filter and this is the output of the filter. Now the questions may be like this. What is the question number 1? Like this, maybe question. The maximum value at the output of filter. The maximum value at the output of the filter, the maximum value. What is the maximum value? The question is, what is the maximum value at the output of the filter? Now say this is the output of the filter. The maximum value at the output of the filter is A square TB, right? The maximum value at the output of the filter is A square TB. But for getting this answer, then what should we do? We want to apply impulse response H of t, and we want to do the convolution of H of t and S of t, then you can get the answer. But impulse response is one step and convolution is another step, and a convolution is a big task, okay? So without doing that, then I will give one small option for you. The maximum value at the output of the filter, whatever the answer I don't know, which is nothing but, in this example, A square TB. Now this A square TB is the energy of the input signal or not? Now see, what is energy? What is the energy? Now this is the energy. The energy which is nothing but power into time. Power into time. Now this is not a sinusoidal signal, a rectangular pulse. What is the power? A square into, what is the time? Time is TB. Is correct or not? Or you can do the integration also. Integration 0 to TB. Now S of t whole square dt, which is equal to integration 0 to TB. Now minus infinity to infinity S square of t dB. That was 0 to TB. S of t square means A square dt, which is equal to A square into TB. Is matching or not? So the maximum value at the output of the filter, if the question is asking the maximum value at the output of the filter, you blindly find the energy of the given input signal. That will be the answer. The maximum value at the output of the filter, which is nothing but energy of the input signal. Energy of the input signal to the filter. Okay, this is the question number 1 answer shortcutly. Now there may be another question. Question number 2. The maximum value will occur at, the maximum value will occur at dash. Okay. Now where is the maximum value? This is the maximum value. The maximum value is A square TB. The maximum value will occur at TB. Am I not? The maximum value will occur at TB. What is TB? Sir, again I want to do the convolution, not required. Now the maximum value will occur at TB. Now this TB is nothing but the duration of the given input signal or not? The maximum value will occur at TB. Now this TB is nothing but the duration of the input signal. What is the duration of the input signal? TB. So the maximum value will occur at TB, which is nothing but duration of the signal, duration of the input signal, or the input signal will be whose information will occur at the duration of the input signal. Okay. Now the question number 3. Yes, okay, these are the major questions generally what he is asking. Right. Now the maximum value at the output of the filter is nothing but energy of the input signal. The maximum value will occur at TB, which is nothing but the duration of the input signal. And if he is asking sometimes signal to noise maximum, signal to noise ratio, which is nothing but find energy of the signal. Okay. Now if asking signal to noise ratio maximum, now whatever the signal, input signal, now that signal energy you find it, signal energy, and divide by noise power spectral density, energy of the input signal. Okay. Now these are the questions generally he is asking. Okay. So here if this is the question, now what is the maximum value will occur at? The maximum value or the energy, everything, the maximum value which is nothing but energy of the input signal. The maximum value will occur at a duration of the input signal. Okay. And signal to noise ratio maximum. Now we'll solve the questions, workbook questions. And one more thing, the maximum value at the output of the filter, or now this is also one more, the maximum value at the output of the filter, this is the maximum value at the output of the filter, and the sample value which is input to the threshold comparator, am I not? That is the sample value which is input to the threshold comparator. Okay. Now if you understand this, you can easily solve any question. Now we'll see classroom workbook question number 1. Now what is the question number 1? A signal represented in time domain as S of t, which is equal to 10 cos S of t, which is equal to 10 cos 2 pi into 10 power 6 into t, 10 cos 2 pi into 10 power 6 into t for 0 less than 10 power minus 4 seconds, and TB which is equal to 10 power minus 4 seconds for 0 less than t less than 10 power minus 4. 0 less than t less than 10 power minus 4. Now this is the question. Now he is asking what is the peak amplitude of the signal at the output of the filter. What is the maximum amplitude at the output of the filter? What is the maximum amplitude at the output of the filter? The maximum amplitude at the output of the filter is nothing but S0 of TB. Is it right? In our case, the maximum value at the output. What is the question? Now this is the question which is given, and he is asking The maximum value at the output of the filter. The maximum value at the output of the filter. S naught of TB. You know that. The maximum value at the output of the filter. What is the question I am asking? The maximum value at the output of the filter, which is nothing but what is the shortcut method I am giving? Energy of the input signal. The maximum value at the output of the filter is nothing but energy of the input signal. Now, what is the energy of the input signal? The maximum value at the output of the filter is nothing but energy of the input signal. Now, this is the input signal whose energy is peak amplitude. This is the sinusoidal signal. Energy is nothing but power into time. This is power into time. Now, which is nothing but power. What is the power? Peak amplitude divided by root 2 is RMS value. Vrms square by R equal to 1 ohm. Now, power into time. What is the time? Now, the time T, TB. Right? Now, which is nothing but 10 square 100 by 2 into TB. What is the TB? 10 power minus 4, which is equal to 50 into 10 power minus 4, which is equal to 5 into 10 power minus 3. This is the maximum value at the output of the filter. Now, which is nothing but 5 millivolts. Now, this is the maximum value, but in the question he is not given maximum value. He is asking peak amplitude. What is the peak amplitude at the output of the filter? This is the peak amplitude. The peak amplitude or a maximum value will be, everything will be same. Okay. This is question number 1. Note down. Now, question number 2. Question number 2, S of t, which is equal to A 0 less than t less than 1, 0 1 less than t less than 2, A 2 less than t less than 3. Now, this is the signal which is given to you, and he is asking same. What is the peak amplitude and what is the maximum value at the output of the filter? The maximum value will occur at a dash. Okay, this is the question he is asking. Okay, so now first we will draw the signal. Now, this is S of t, which is nothing but in time domain. Now, 0 to 1, 0 to 1, which is nothing but amplitude is A. 1 to 2 is 0, and again 2 to 3, again 2 to 3, which is nothing but A. Now, this is S of t. This is S of t, right? Now, and he is mentioned, and in the question, the maximum value occur at, okay, now you tell me. Now, here, I will take one question, in question number 2. The maximum value will occur at, what I am saying, the maximum value will occur at dash which is nothing but the duration of the input signal. What is the duration of the input signal? The maximum value will occur at the maximum value will occur at t. What is t? 3 seconds. The maximum value will occur at dash t equal to 3 seconds. Now, next question here. The maximum value will occur at t. T is the duration of the input signal. Then he is asking the maximum value at the output of the filter. The maximum value at the output of the filter. The maximum value at the output of the filter, which is nothing but energy of the input signal. Am I not? Now, what is energy of the input signal? Which is nothing but energy of the input signal. What is energy? Energy is nothing but power into time. A square into t. T is 1 minus 0 plus now 1 to 2 is 0. Now again a square into now 3 minus 2. Now this is the energy of the input signal, which is equal to a square plus a square, which is equal to 2a square. Now this is the energy of the input signal. Is nothing but output of the filter, the maximum value at the output of the filter. Okay. Okay. Now classroom workbook question number 3, and there is a linked answer. Question number 3, A bit and B bit both are available. Okay. Linked answer. Okay. Now there are two signals which is applied to the match filter. Now one signal is this one, S1 of t, which is given as S1 of t, which is given as this. Now this is the first signal which is applied to the match filter 1. This is the first signal which is applied to the match filter 2. And this is the second signal which is applied to the match filter. This is the signal which is applied to the another match filter. Sorry. Now this is the signal which is applied to the first match filter, and this is the signal which is applied to the second match filter, which is nothing but B cos two pi into T naught minus T naught minus T by T, T naught minus small t by capital T. Now this is the signal which is applied to the second match filter. That is the signal which is applied to the first match filter. Then he is asking what is the signal to noise ratio of a match filter? What is the maximum signal to noise ratio of second match filter? Okay. Now very simple question. Now this is the signal to noise ratio. This is the maximum signal to noise ratio of match filter 1 is energy of the input signal to the noise power spectral density. Am I right? Not energy of the input signal to the noise power spectral density. Now he says that the noise power spectral density is n. Now which is nothing but what is energy of the input signal? Energy of the signal, which is nothing but energy power into time. Power into time. What is the time? This is the time, which is nothing but t by 2 plus t by 2 is t. This is t. Okay. Now divided by this is The noise power spectral density is given as n by 2. So finally, which is nothing but 2a square t by n naught or n. Now this is the signal to noise ratio of first match filter. Now what is the signal to noise ratio of the second match filter? This is the signal to noise ratio of match filter 2, and this is the signal to noise ratio of match filter 1. This is match filter 1, this is match filter 2. Now this is the signal to noise ratio of match filter 2, which is nothing but same Es by n naught by 2, which is nothing but energy, power of the input signal. Power is, what is the power? V square by, because this is a sinusoidal signal, power into time. Now this is B naught, the second signal over a duration of TB seconds, by n naught by 2, which is nothing but n naught by 2 is nothing but n. Now therefore this is nothing but 2 cancel, B square T by n. This is the signal to noise ratio of match filter 2. This is the signal to noise ratio of match filter 1, that is A bit. Determine signal to noise of match filter 1, determine signal to noise of match filter 2, maximum signal to noise ratio. Now B bit is, if both match filters signal to noise ratios are same, then find the relation between A and B. What is saying? If both signal to noise ratios of the match filters are same, signal to noise ratio of match filter 1, which is equal to signal to noise ratio of match filter 2. If both signal to noise ratios of match filters are same, then find the relation between A and B. 2a square t by n, which is nothing but b square t by n, n cancel, t cancel, which is nothing but now a, which is equal to b by root 2, or b equal to root 2 into a. Okay, this is the relation between A and B. This is the question number 3, linked answers. See here, sometimes in the question maximum value or sample value, both are same. The sampled value, both are same. The maximum value or the sampled value. Now question number 4. Now question number 4 is, a signal which is applied to the match filter S of t a signal which is applied to the match filter is this. Then same. Now he is asking the question number 1 in 4-bit. The sample value. Now what is the question? The sample value. The sample value or a maximum value? The sample value or the maximum value at the output of the filter. The sample value or the maximum value at the output of the filter, which is nothing but the sample value or a maximum value at the output of the filter is nothing but energy of the input signal. The maximum value or a sample value at the output of the filter is nothing but the energy of the input signal. Now we want to find, now this is a slope. Now this is the slope which is nothing but 0, 0. Now this is 1, 1. Change in y-axis by change in x-axis. Now this is nothing but this is a ramp signal, a linearly varying signal with a slope of 1. So the sample value, which is nothing but, what is nothing but energy of the input signal. The sample value in a shortcut method, which is nothing but energy of the input signal. Now what is energy of the input signal? 0, 2, 1 into t square dt, x of t dt plus now 1 to 2. Now 1 to 2, this is energy if you find between 1 to 2. 1 to 2 is nothing but power into time, energy equal to power into a square into time. Time is nothing but 2 minus 1. Energy equal to power into time. And this is over duration of 1 to 2. So the sample value, which is nothing but integration t square is nothing but t cube by 3 over a duration of 0 to 1 plus 1 square into 1. So which is nothing but 1 by 3 plus 1, which is equal to 3 plus 1, 4 by 3. Now this is the energy of the input signal. This is nothing but the maximum value at the output of the filter or the sample value at the output of the filter, which is nothing but the energy of the input signal. And next, what is the other question? Now where is this maximum value occur? The maximum value will occur at the maximum value or the sample value will occur at t equal to duration of the input signal at t equal to 2 seconds. The maximum value will occur at t equal to 2 seconds. See, if you have any doubt, then you go for the convolution and these answers will be same or not, you can cross check. Question number 5. Now this is the signal which is applied to the input to the filter. Then the same question. Now what is the sample value? The sample value or the maximum value at the output of the filter is nothing but energy of the input signal. Energy of the input signal. What is the energy of the input signal? Now this is power into time. What is the power? Power is nothing but 2 square into time. Time is nothing but t minus t by 2, which is equal to now 2 square means 4 into t minus t by 2, t by 2. Now 4 into t by 2, 2t. Now this is the sample value at the output of the filter or a maximum value at the output of the filter. Now the maximum value will occur at capital T seconds, which is the duration of the input signal. The maximum value will occur at T equal to T seconds, which is the duration of the input signal. Okay. Okay. Now this is question number 6. Question number 6. A matched filter has a frequency response of, means frequency domain. A matched filter has a frequency response of h of f, which is equal to 1 minus e power minus j 2 pi ft by j 2 pi f. A matched filter has a frequency response given as, matched filter has a frequency response is given as this. Now he is asking, now if the filter is matched filter, if the filter is a matched filter, then what is the input to the filter? Okay. Now this is the frequency response of matched filter. This is the frequency response. This is the frequency response of matched filter. Now what he is asking is, if the filter is a matched filter, then what is the input signal to the filter? That is the question he is asking. Now first you find, now this is h of f, can I write like this? 1 by j 2 pi f by 1 by j 2 pi f into e power minus j 2 pi ft. Now therefore this is h of f, which is equal to 1 by omega j 2 pi f. Okay. Now 1 by j omega by 1 by j omega into e power minus j omega t. Therefore h of f, which is equal to 1 by s by 1 by s into e power minus st. If you apply inverse Laplace transformation, h of t, which is equal to, now this is 1 by s, inverse Laplace transformation is now u of t minus u of t minus t. Okay. The inverse Fourier transform, u of t minus u of shifting t minus t. Now this is the impulse response. This is the impulse response of the matched filter. But what is the question he is asking? Now this is h of t. What is h of t? H of t is nothing but, now see here, this is h of t. This is u of t minus u of t minus, sorry, this is u of t and minus u of t minus t. Now this is u of t minus t. Okay. Now this is u of t, this is minus u of t minus t. Then if you subtract, now this is h of t, which is nothing but the common portion. Now from this, this is 0 to infinity, this is t to infinity, then this area will be cancelled. Now this is 0 to t, no, this is 1. So this is the impulse response of matched filter, now which is nothing but this one. But what he is asking that the impulse response of the matched filter, now this is a matched filter. Now if this is a matched filter, the impulse response is matched with the input signal. Therefore this is h of t, this is the impulse response of the matched filter, is matched with the input signal. Therefore s of t, the input signal to the filter, will be matching with the impulse response. Therefore, this is the answer. This is the input to the matched filter, because now the impulse response is matched with the input signal. Therefore, the input to the filter will be same as the impulse response will be matched to the input signal. Now here there may be questions are asking here. Now the maximum, the peak amplitude is peak amplitude is nothing but energy of the input signal A square into T, which is equal to T. Now the maximum value will occur at T equal to capital T seconds, which is the duration of the input signal. Okay, no doubt. Now question number 7. Question number 7 is input to the matched filter is as shown in the figure below. Input to the matched filter is nothing but S of t is as shown in the figure below. Input to the matched filter is as shown in the figure below. This is the input to the matched filter as shown in the figure below. Then what he is asking is determine slope in impulse response in the interval 3 to 4. So if you want to find the slope in the interval 3 to 4 in the impulse response, first we need to find the impulse response. Now how to find the impulse response of the matched filter? There are two steps. Okay. Now what is the step 1? First, what is the step I am saying? First you fold the signal. Fold the signal. Now this is the fold the signal. Now step 1 is folding. Then what is the step 2? Step 2 is shifted to the right side. Okay. Now if you shifted to, this is the step 1, folding. Step 2 is shifted to the right side. Step 2 is shifted to right side. Then if you shift it to the right side, Now first one is folding and second one is shifted to the right side. Now this is nothing but the impulse response of match filter, right? Now this is the impulse response of the match filter h of t. Now determine the slope in the impulse response in the interval 3 to 4. Now this is in the interval 3 to 4. Now in the interval 3 to 4 means this is 3 comma 1. Now this is 4 comma 0. Now what is the slope? The slope, which is nothing but change in y-axis y2 minus y1 by x2 minus x1, which is equal to now 0 minus 1 by 4 minus 3. Now this is nothing but the slope in the interval 3 to 4 in the impulse response. Okay. Now this is question number 7. Question number 8. Now this is the signal which is input to the filter. Now find the impulse response. Same. What is the first step? Now just folding. Now this is step 1 is folding. Then what is the second step? The impulse response, which is nothing but shifted to the right side. Just shift to the right side.